Hello and greetings from Gardnerville. First thing we're going to work on is assignment 9.1. If you haven't downloaded it, please look at it or printed it or whatever else you can do. Again, instructions will be on the website, so go get them. But if you've got this video, you probably already looked there. Okay. So what is it we're going to do first? We're going to talk about something called Amber Wand tricks, magic tricks. Okay, so what you may not know, brief history lesson. The word in Western Europe for somebody who was a student, who learned a lot, was a sage. In Eastern, in the Holy Roman Empire, they called those mages. And so, if you're a student and you wanted to make some money, what you'd do is you set up a little cart and you'd grab yourself a stick of amber. Now, sticks of amber cost quite a bit of money, so I'm going to use a comb. Like, what's this thing in the front? Hold on a second, I'll get there. Okay, so they would use a stick of amber, and they'd grab silk. Again, silk's expensive, so I'm going to use flannel. And they would perform tricks of learning. Okay, and if you're a magus, the act of being a magus was your profession was magician. And when you did it, you were doing magics, not ick, but we're close. And so I'm going to take my amber rod, and I'm going to take my bit of silk, yes, and I'm going to rub them together. That's all I'm going to do. I'm going to rub these things together. So people are doing this in 500 AD. We know this on the streets for coins. Okay. Your original beggar student, way to get a student loan was to hang out in the streets and show all the learning you were doing. So in front of you in the foreground is, it's called a pith ball. It's attached to a ribbon because I don't have any string in the house. I know it's coming to the end of the world. No, it's not. It's just me not having string in the house. So the string, so I've attached a piece of ribbon to a bit of aluminum. It's not aluminum, there's a piece of cork inside the aluminum, so we call that a pith ball. We put aluminum around sprayed on aluminum around that, a bit of cork. And what pith balls do really, really well is they show the following trick. So I'm going to come in this way, hopefully. It's going to be like reverse Polish, look at the camera, try to do the same time. And I'm going to get close to the pith ball, and hopefully you're going to see it do something strange. I'm not touching it, and yet it is moving. It is moving currently towards my comb because it likes my comb. And you might be thinking, that's very strange. Why would a piece of aluminum with cork in it like my comb? And so this is where you throw coins in my purse, and I get all excited about the fact I can afford food and perhaps another lecture or two. I'm going to go a little farther. I'm going to keep the comb coming until I come in contact with it. And I'm going to tap it lots of times until I really just beat the heck out of it. Okay, so now when I get close to it, oh, it still wants to get close. I haven't done enough job yet. Hold on. More mess with pith ball. Come on, pith ball, get it all. There you go. Get some more. Get some more. Get some more. Okay, here we go. See if I can make it do what it's supposed to do. Huh. Not getting much out of it. Okay, need to give it some more. Hold on. More rubbing. Now, if you notice, it's not moving towards my comb anymore. It's moving. Now it's hard to see with the camera. It's partially moving towards, partially moving away. So if you notice, it's now trying to move away. Why would that be? Okay, something has different. So I'm going to tap it some more. So I get to do it even more because that wasn't really clear what was going on there. All right, let's see if I can get to move some more away. You can see it's moving away. I'm not touching it. It looks like I'm touching the tape. I'm not actually touching the tape. It's moving away. Okay, so other tricks that work the same way. Here's something I borrowed because my sinks at my house are all white, and watching water in a white sink No matter what the camera angle, not great. So here's something I borrowed. They rubbed a comb. They get it done on the side. Then they're going to hopefully turn, oh, I didn't turn on the video. It's hopefully turn it. They turn on a stream of water. And your stream of water is consistent. Bring up your comb next to it, and the water does something creepy, which is especially powerful because back then they believed that the water was an element, and so therefore if you could make an element move like that, you were clearly doing something truly remarkable. All right, comb on bits of confetti. Rub it on your, this guy actually ran it through his hair, but you know, you can rub it on a piece of flannel like I did, or silk. He's doing his hair right now, I believe. Yes, he's doing his hair right now. Look at that. That's great. Let's get to the punchline. So he did it before. Nothing happened. Rubs in his hair, and the magic that is. I want you to notice that a couple of these things hit and bounced off. See that guy right there? He's hitting and bouncing off. So some of them are sticking, and some of them are hitting and bouncing off. That's much more interesting. And then you see when one finally leaves the comb, it takes off and flies way over here. Okay? All right, so the question at hand is, what the heck is going on? What is going on? Well, a guy named Ben Franklin, who you should have heard of, but in a totally different context, was the preeminent physicist of his day when it came to electricity. And Ben, good old Ben, parlayed that into being able to visit French courts and show magic tricks. He used to actually wear a coonskin hat on top of his head. It means raccoon for those of you who don't yet know anything. You have a raccoon skin hat, and he'd walk around with, in fact, an amber or a glass rod. And he'd take that and he'd rub it against his hat a lot. And he'd walk around moving water, moving confetti, making the hair stand up on a person's head, and all of that was learnedness. Okay? Now, he realized the key was in the rubbing two things together. In fact, at school, if we ever get back to such a thing, there's something called a Graaff Generator. And usually I open it up, and all it is there's a big rubber belt in it. So hopefully you've seen one of these before. And a metal top. And there's a little bitty comb on it. And so what happens, that comb is attached to the metal shell. And so what happens is I turn on the motor, the little rubber band goes like this. It rubs the cone. That creates electrons, which now flow on the outside of this. And then it shocks innocent children, and it's great fun. So rubbing two things together creates this stuff called electricity, electrifying. He also realized something interesting. He said, when you bring your amber rod, we brought a comb, you bring your amber rod close to an object, it's initially attracted, then repelled. And he thought, okay, so what must be happening inside here? And then later on, when I tapped it, let me back up, when the two tap together, the two want to run away from each other. Okay, so he's did some thinking and thought, what must be happening here is when I touch, something is jumping across to here. Okay, so he thought that there was a negativity. Sorry, I shouldn't say that. He thought there was one type of charge, and that type of charge would jump from one to the other. Once they both had the same charge, they were repelled. So he thought in this first case, he thought, well, if I bring the wand close to it, the fluid that is repelled by this wand would drift over this way and gather there, and that which was, and then the other stuff would be here, and it must be attracted to the wand. So he thought, aha! So what must be happening here is when I bring it close, and I'll try to blow this up so it's a little bit better, that there are two fluids inside of your device. And the fluid that doesn't like it runs this way. The fluid that likes it goes this way. And that means the like it's closer than the doesn't like it, and so it's attracted. But the moment you touch, this evil fluid jumps onto here, and that evil fluid means now they're repelled from each other. Okay? So this became Ben Franklin's model. There were fluids inside of everything, and if you rub two things together, you're going to scrape off some of that fluid. If you scrape off some of that fluid, if it's the same fluid, they're repelled. If it's the different fluids, they're attracted to each other. Now, what started him down the road of interesting fun was that he thought, well, you know what's really interesting? What happens when the fluids are returned back where they started? Well, nothing. So he thought, well, that means maybe they have equal amounts of evil fluid and good fluid. Okay, so I got evil fluid and good fluid, and that makes the thing neutral. Okay, and so if I have equal amounts flowing throughout, as long as I don't bring something close to it to extract good and evil, I actually have a fluid that is neutrally balanced. Now, he didn't believe in evil and good, and I made those things up, but he started to think in terms of, well, what happens? Why does this have no effect? He thought, well, if I have equal amounts of these two types of fluid, then I must have a net electrification, which we're going to call charge, of 0. Which means one of these is a positive fluid and one of these is a negative fluid. And when you put them together, +1 and -1, you end up with 0. And so he thought, aha, I just have to decide which one is positive and which one is negative. So he did the logical thing. He went outside, and there were clouds passing overhead, and he put a little kite out there, and he put a string, and then he captured it on a key inside of a bottle, and he scraped the clouds, rubbed the clouds, got the electricity to come down his line into his key, and he electrified the key, and then he figured out what charge the key was. He determined that key was positive, and since he knew clouds strike the ground with lightning, he figured the positive ones were the ones that moved. Reasonable, right? Right, so positive moves. So he figured that would make all our lives better because obviously we want positive flow to be what moved. So it turns out Ben was wrong. What happened was Ben's kite situation. You got your kite, you're scraping the clouds. When you scrape the clouds, positive charges move along here and fill up your little jar. And that only happens with lightning because lightning is extraordinarily powerful. So he got it wrong. So he labeled the charges he thought were moving positive, and it turns out we know that protons are 10,000 times more massive than electrons. That's too many zeros. Than electrons. So that's equivalent to saying a hummingbird attached to a bungee cord attached to a bus. Okay? Now, we will note that the forces on these positive charges and negative charges are the same, but here's the problem. The problem is if I have a bungee cord, which would pull it equally both ways, if I take the hummingbird and pull it this way, and I take the bus and pull it this way, when I let go, the bus ain't going to move very much. And that's what happens in electricity. The electrons are the ones that move. The negatively charged particles are the ones that move. And so we end up with a situation by which we have everything backwards. It is why when you gain electrons in chemistry class, you gain a negative charge. We went almost 100 years without realizing the mistake we made, and after that, us old people didn't want to change it. So the bottom line is we're going to deal with this a little bit in physics where we have the wrong charges moving. We can thank Ben for that. All right, going to stop this video. Going to start the next one.